Okay, here we're doing grade 11 maths paper 1, the 2018 paper. Let's start with question 1, which is algebra. Okay, so 1.1 says x times 2x plus 1 equals to 0. Okay, so this is a quadratic equation, and how do we solve it? Well, they've already factorized it for us, so we have two factors. We have x and 2x plus 1. Okay, now remember, if you multiply two numbers together, let's say a and b, and they have to equal to 0, the only way for this expression to equal to 0 is if one or both of the numbers are 0. Okay, so if, for example, if I have a times 0, so we're saying that b is 0, then we'll get 0. Or the other way around, let's say I have 0 times b, that will give us 0, or 0 times 0 gives us 0. Okay, so that means that either one of these factors have to equal to 0. So I'm going to say x equals 0 or 2x plus 1 equals 0. Okay, so this is already solved, and on this side we just bring this to the other side and divide by 2. So we'll say x is equal to minus half. Okay, so that's our two answers. Okay, next question, 1.1.2. 1.1.2, you can see it's another quadratic equation. And see, for this one here, it's trinomial, it's not yet factorized. So the easiest way to solve something like this is to just use the quadratic formula, which is minus b plus or minus the root of b squared minus 4ac all over 2a. Okay, so now we just substitute in. So we'll have x is equal to minus b, so minus 2 plus or minus the root of, and then b squared, so 2 squared is 4, minus 4a is 5, and c is minus 6, all over 2a, so 2 times 5. Okay, let's simplify that a bit. So I'll have minus 2 plus or minus the root of, and now I'm just going to put all of that into my calculator. So I'll say 4 minus 4 times 5 times minus 6, and that gives us 124 over 10. Okay, now I can split this up. So I can say x is equal to minus 2 plus the root of 124 over 10, or x is equal to minus 2 minus the root of 124 over 10. Okay, so let's evaluate each of those on our calculator. So I'll have minus 2 plus the root of 124 over 10, and that gives us 0.91, or minus 2 minus root of 124, and that gives us negative 1.31. Okay, and then you obviously, now you can take these two x values and substitute it in this original equation, right? So you can start with 0.91 and put it in place of x and see if you get 0, and then do the same for this, and if they come to 0, that means your answers are correct. Okay, let's do the next one. 1.1.3, that's an inequality. So we'll have 2x squared minus 2 is greater than or equal to 3x. Okay, so it's going to be quadratic as well. So we can start by making this 0. So let's just bring this minus 3 to the side. Minus 3x minus 2 is greater than or equal to 0. Okay. Now the first thing here that you have to do is find what's called the critical values. So you first have to find when this expression is equal to 0. Okay, so we'll say 2x squared minus 3x minus 2 equals 0. Okay, and now you can either use the quadratic formula, or you can just find common factors and do that. I'm just going to use the quadratic formula here. So minus b plus minus the root of b squared minus 4ac all over 2a. So I'll have 3 plus or minus 9 minus 4ac all over 2a. Okay, and I'll put this part here under the square root into my calculator. So 9 minus 4 times 2 times minus 2 gives us 25 over 4. Okay, so that means we'll either have x equals to 3 plus 5 over 4, or x is equal to 3 minus 5 over 4. And I'm saying 5 because the square root of 25 is 5. Okay, so this side will give us 2, and this side will give us minus a half. Okay, so now let's think about this. So the original equation that we had, if you think about functions, what function does this look like? This is a concave up or a happy parabola, right? So I'll draw in the x-axis here, and let's look at the question. They're asking for the values where this parabola is greater than or equal to 0. Okay, so if we look at our parabola, what did we solve for when we solved for x? Well, we equated it to 0. And when does the parabola equal to 0? At the x-intercepts. Okay, so the two values that we solved for here, those are the x-intercepts. So this is minus a half and this is 2. Okay, and the question is asking for when this parabola is greater than or equal to 0. Okay, so this occurs at these values here. Right, because if you look at it, everything beyond this point, beyond the x-intercept this way, the parabola is greater than 0, and anything beyond this point, it's also greater than 0. Okay, and obviously at the x-intercepts they equal to 0, so that satisfies our two things. So we can see that therefore x either has to be less than or equal to minus half, or x has to be greater than or equal to 2. Okay, and that's our final answer. Okay, 1.1.4. So this says root of 2x plus 5 minus 3 over root of 2x plus 5 equals to minus 2. Okay, so if we look at this nicely now, you can see that we have this repeated twice, that root of 2x plus 5. Okay, so what we can do is we can set that. We can say let the root of 2x plus 5 equal to, let's say, k. Okay, you can pick any variable, but let's just say k. So now we're going to rewrite this expression on top here, but in place of root of 2x plus 5, we're going to say k. So k minus 2 over k equals to minus 2. Okay, and now we can just solve for this as if we were just solving for k. So let's get rid of this denominator by multiplying through by k. Okay, let's bring this to that side. K squared plus 2k minus 2 equals 0. Okay. Oh, so I realized this is supposed to be 3, sorry. So this is 3, this will become 3 then, and this will become 3 as well. Okay. And now we can, let's just use some common factors for this one. Okay, so remember when we try and expand this trinomial, we have to find two numbers that when you add them together, it must give you that minus 3. And when you add them together, it must give you 2. And when you multiply them, it must give you minus 3. Okay, so what two numbers is that? Well, let's think about the factors of 3. So 3 only has 3 and 1. It's a prime number. Okay, so that means that the only factors we can think of would be 3k minus 1k or k. Okay, so if you look at that now, if I take 3 and multiply it by minus 1, I'll get minus 3. And if I take 3k, or if I just say 3 minus 1, I'll get 2. Okay, so that's this. Okay, so you can see when I add them, I get to 2, and when I multiply them, I get to minus 3. So that means that this is going to work. Okay, so let's just factorize this now. So we'll have k plus 3 minus 1, k plus 3, and it's equal to 0, equal to 0. And now I can factor out the common factor of k plus 3, and I can equate them both to 0. Okay, so so we got till that point, but remember up here we said that k is equal to 2x plus 5. So now we're going to take each of these equations and equate them to our original thing. So we can say root of 2x plus 5 equals to minus 3, or the root of 2x plus 5 equals to 1. Now right off the bat we can immediately discount this solution, okay, because if you think about it, we have a square root of something and we're getting a negative answer, which is impossible, right? There's no way to get the square root of something and get a negative answer. Okay. So this is not possible, so there's no solution on this side. On this side we can still keep solving, so let's square both sides. So we'll have 2x plus 5 equals to 1, and then we can just solve for x here. So minus 5 on that side, so 1 minus 5 is minus 4, and then divide by 2, you'll get minus 2. Okay, now you can take this answer of x equals minus 2 and you can test it in this original equation up here, and if you substitute in x and you get minus 2 at the end, that means that your answer is correct. Okay, let's look at the next one. It's a simultaneous equation. So, okay, so two equations are, this is 1.2. Our two equations are y plus x equals 2 and x squared plus 3xy plus 8 equals 0. So x squared plus 3xy plus 8 equals 0. Okay, so let's isolate one of our variables. So here I'll just isolate y, but you can do it for x as well. So we made y the subject of the equation. We call this equation number 1. We'll call that equation number 2. Okay, so now let's say sub equation number 1 into equation number 2. So I'm going to rewrite equation number 2, but in place of y, I'm going to put our new equation. Okay, so x squared plus 3x times 2 minus x plus 8 equals 0. Okay, so now I have x squared plus 6x minus 3x squared plus 8 equals 0. Okay, group my like terms and add them, so I'll get minus 2x squared plus 6x plus 8 equals 0. Okay, and then I can divide away by minus 2 because it goes into each of those just to simplify things a bit. So I'll get x squared minus 3x minus 4 equals 0. Okay, and again we're going to look for a number that when you add it, it gives us that, and when you multiply them, it gives us minus 4. So x squared minus 4x plus x minus 4 equals 0. Okay, let's see if that makes sense. If I take minus 4 plus 1, I get minus 3, and if I take minus 4 times 1, I get minus 4. Okay, so there's my minus 3 and there's my minus 4. So that means that these two numbers are going to work. Okay, so now it's just a case of factorizing everything. And now we can take out our common factor. Okay, again we can equate each of these to 0 and we get two answers, right? And now at this stage you can test if your answers are correct. So you can take 4 and minus 1 and sub it in wherever you see x. So you start with 4, wherever you see x you substitute it in, and if you get 0 that means your answer is right. And then you do the same for minus 1. Okay, but anyway, once you get your answers, now you can call this equation number 3, call this equation number 4. Okay, so take sub equation 3 into equation 1, which was this equation here, and at the same time you can sub equation 4 into equation number 1. Okay, so equation number 1 is y equals to 2 minus x, right? But now in place of x we're going to put 4. Okay, so that means y equals to minus 2. And on this side, y equals to 2 minus x. So in place of x, we're going to put minus 1. Okay, so y equals to 3. So that's your answers there. So you're going to end up with 4 answers, 2 x values and 2 y values. Now to test if your answer is correct, you start with, let's say this first case here, where you have x equals 4 and y equals minus 2, right? So you come into this first equation, you sub in minus 2 for y and 4 for x, and you should get 2. And here you sub in 4 for x and minus 2 for y, and you should get 0. Okay, and then you do the same for that. And if you get the right answers, that means that your answers are correct.